This section we're going to be taking a look at is the inclined plane portion of the simple machine packets, starting with question 18. It's talking about putting together some information related to a wheelchair accessible ramp. As it says, the slope must be 112 or less. Also, it says that vertical distance is going to be 2 feet, or the overall height. So if we take a look at the diagram and look at this ramp, we know that this section down here would be considered the run. Over here we're going to have a height of 2 feet, and then this side of the ramp, or essentially the triangle, is going to be the length. And keep in mind that we want to have a slope of 112 or less. And you could think about that as a practical application, as we have ramps in culinary, and those have to be a particular slope so it's safe for people to get up and down. So think about that diagram as we move forward. Looking at number 19, it says the ADA Accommodation Code, or the Americans with Disability Act code. It's set up to allow people fair access into buildings and throughout public buildings. So if we want to figure out the minimum length of the ramp base, what we'd have to start doing is thinking about the formula we're going to plug in, and essentially we would have the slope, and that's going to be equal to the rise over the run. But if we're going to solve for the run, we would really need to kind of rewrite this formula. So if we're going to rewrite this, after we shift things around, we would have that the run is equal to the rise over the slope. So if you go back to our previous problem and look at some of those numbers, you should be able to plug that in and come up with a distance, and that answer should be in feet. So let's move that off to the side. And moving on, it says using the known height and the calculated base length that you just figured out in number 19, what's the overall length of the slope? So for number 20, what we're going to start doing is plugging in some information here that we know, and being that we're working with a triangle and we're trying to figure out the other side, we're going to use Pythagorean's theorem. So we know a squared plus b squared equal to c squared. And you know some information here. You know that side A is going to be 2, so we have 2 feet. And then you're going to also plug in B. So obviously this is A. And then B is the information you're going to plug in from the previous problem. And you can take it from there. Finish up number 20, plugging in those few numbers and using Pythagorean theorem. Moving on to 21. Let's take a look at that. It says, what's the ideal mechanical advantage for the ramp? And in this particular case, we know that mechanical advantage is going to be equal to the, in this case, the length over the height. So we can go back and look at some of the information you gathered from previous problems. The height, you know that is going to be 2 feet, and the length is what you should have come up with from this problem. And that should give you a mechanical advantage. Finally, number 22. What we're going to look at there, it says a person and the wheelchair have a combined weight of 185 pounds. How much ideal effort force is required to travel up the ramp? So if we're looking at this particular problem, we're going to know that the mechanical advantage is equal to the resistance over the effort. From the previous problem, number 21, you should figure out or know what the mechanical advantage is. And we know that the resistance is going to be 185 pounds. So we really need to rewrite this formula if we want to solve for effort. It's asking here how much ideal effort force is needed to get that person up the ramp. So what we would do is go back to that formula, and if we're going to solve for E, E needs to equal 185 pounds. We know that that's the resistance. And then down here we are going to have our MA. And that's from the previous problem. So go ahead and plug in those numbers and see what you come up with for E. Hopefully this helped you out for those few problems related to inclined planes.